Hello, welcome back. We're doing tutorial sheet 5, question 6 in ME4111, and we're working through the equilibrium problems. So in this question, it's moved into 3D, so it's getting a bit more complicated. We're asked to determine the magnitudes of the forces F1, F2, and F3. Oh, F1 is this guy, F2 is that one, and F3 is that one. So they're necessary to hold the force F equals this in equilibrium. So F is this guy here, and we're given the coordinates, or sorry, the components of F. So we require F1, F2, and F3. So just a sanity check is there's 3 unknowns, and there's 3 equations I can apply based on the sum of the forces equals 0. This is a point mass problem, so all the lines of action of these forces are going through a single point there at the origin, and that means that there's no turning effect, so no rotational effects. So the sum of the moments equals 0 just gives you the trivial solution. Just having a look at this, I want to check, do I have directional information? So I don't have the magnitude, that's what I'm after. So on F1, yeah, I have all the info there. F2, got that, and it's giving me the angle there as well. So I have each thing with respect to the axes, that's fine. F3, I don't have any angles, but I have a point coordinate down here that the line of action passes through, and it starts at the origin. So I can work out the unit vector for that. So that'll be fine also. So I have the directional information for those 3. And I have all the info for that. So yeah, I can solve 3 equations, 3 unknowns. Now, any second, this will pop up. There we go. So what I'm doing is I'm taking the sum of the forces equals 0. And the first thing I want to do is to break each of those forces into their components. So the first force I have is the one that I was given, which was F. So I've just written that out in vector form. The next force then is F1. And we can see that this one is going off direction. And what I'm after is a component coming out this direction here. And I also want a component going that direction. And I want the Z component of it also. Okay, so that's what I want to break it down into. So if I look at this, I'm given the angle of 60 degrees here and angle of 30 degrees. So if I take F1 cosine of 60, that will put me on this line here. Okay, and what I can do then is take the cosine of that, which will give me the x component. So F1 cosine 60 sine of 30, sorry, cosine of 30 will give me the x component of that. So actually that's what I've written out there. But F1 cos 60, which is, just go back a bit. Which colors the orange is a bit minky. Right, so this bit here is the F1 cos 60. And then taking the cosine of that, if I go to the pinky color, that now gives me this. Okay. And for the y component, it'll be this bit, which is the sine of the F1 cos 60. Okay, so that's that bit there. F1 cos 60 sine 30 j hat. That's acting in the negative y direction, so I have a minus on that. And then the vertical component here is F1 sine of 60, which is in the positive z direction. So that gives me the k hat version of it there. So this version of it here. Okay. And that's this bit here. So I've written over there F1 sine 60. Okay, so that's F1 broken down to its 3 components. We've had problems like this before in one of the other tutorial sheets. All right, so I'll clear that. Next force is F2. On this one, I'm given the angles. So I'm given the angle 60, 60, and 135. So if I take the cosine of those angles, that'll give me the component in the respective x, y, and z directions. So I have F2 cos 135 I hat plus F2 cos 60 j hat plus F3 cos 60 k hat. All right, so that one is handy enough. And then for the last force, F3, I need to work out the unit vector for this. So if I'm standing at the origin, I want to get there. I go 4, 4, and minus 2 in the x, y, and z respectively. So it's plus 4 I hat, plus 4 j hat, minus 2 k hat. I forgot that hat in the k there. And divided by the magnitude, which is 4 squared plus 4 squared plus minus 2 squared, the square root of all that. Okay, so that gives me 4 over 6 I hat plus 4 over 6 j hat minus 2 over 6 k hat. So you can simplify that down. So I've just multiplied then that unit vector by F3, the magnitude. Okay, so I've got F3 times 4 over 6 I hat plus F3 4 over 6 j hat minus F3 2 over 6 k hat. Now that's each of the forces broken down into their components. So what I'm going to do next is just take all the I hat terms. So this one, this one, this one, and this one, and sum those up and set them equal to 0. Then I'm going to go take the j hat terms for these guys, sum all those up and set them equal to 0. And lastly, I'll take the k hat terms, so the minus 5 k hat there. I have this bit here, this one there, and this one there. So I'll sum all those up and set them equal to 0. Okay, so on my next slide, here we go. I take each term, sum it to 0, like I said. So that gives me a system of 3 equations, and I have 3 unknowns. I think you just churn the wheel through that. There's a variety of different ways of solving it. The most efficient way, you've probably seen in maths already, is to use a Gauss elimination. So to reduce the reduced row echelon form of the matrix, I think is the terminology. But anyway, you can solve this as 3 equations, 3 unknowns. You just crunch through it. It's a mathematical task, and you end up with this as your solution. Okay. Again, in terms of assessment, you know where to put your resources into. You put your resources into defining these sets of equations with the 3 unknowns, and that's where most of the marks are going. And then there'll be a couple of bonus points going for crunching the numbers and being able to work out the things. But if your method is sound, you get the majority of the marks, because I'm most interested always in your approach. Are you applying the correct principles? And it's fine to make a simple calculation mistake. So you should be very comfortable solving those kind of things anyway. They're not traumatic. If you have any questions on any of that stuff, make sure you come back to me. I suppose just to summarize, in breaking the forces, sorry, not too far, into their components, you know, we've used 3 different approaches. One was given angles and taken the angles with respect to a plane, and then that component relative to the 2 axes. So breaking it down that way, then we had the cosine of the angles with respect to the vectors making with respect to the different axes. So the cosine of that, and then lastly we had the unit vector approach. So it actually brought all 3 techniques in together, which is nice to do. So it kind of tests your ability to decompose vectors into components. And then we just do the summation here with the sum of the forces equal to 0 to get our 3 equations, 3 unknowns. Okay, thanks for listening, and we'll see you again.